get started. Get something up on the screen here. So Megan was asking if everybody got, if everybody got their Postgres installed. I think everybody did, right?
I think so.
We're good to go.
Yes, we scored. Okay, so that means I wrote good instructions and we're good to go there. Awesome. So I've built out kind of like an agenda because we planned this to be a two session workshop. So we're hoping that if you like it now, that you'll come back again next time. Or if you have something that you didn't learn today and you want to learn next time, you know what we're going to cover. So today we're gonna verify the installations are good. So we've done that. Check. We're going to go over the Postgres admin interface, and I'm going to kind of talk to this a little bit, draw some correlations between this and Microsoft SQL Server Management Studio, which is probably a lot like, MySQL Workbench. I mean, they're all pretty similar, which I think is actually a good thing to point out because I got stuck for a time thinking, well, I only know how to do Microsoft SQL, so I can't do Postgres. It's going to be too hard. In actuality, it's not. They're all very similar, which is good to know. So we're going to manually create a database using the UI, and we're going to manually create a table. Just so you guys can, if you've never done it, you can kind of see and understand, exactly how it's done. Put your fingers to the keyboard. But after that, we're going to use that script that I provided in the download instructions to actually create the database, because that would take, we'd be here for days if we had to create all this stuff by hand. So it'll give you a sense of, putting your fingers on the keys, figuring out like how it works and what you need to do, and then we'll just create and populate this database, which is super handy. The database that we're using is actually AdventureWorks. So I don't know if any of you are familiar with this database. Yes, some yeses out there. So AdventureWorks is actually Microsoft's kind of like their sample company database. So it's used in all of their tutorials and their books and their online resources. So when they're describing concepts in SQL, they're going to reference the AdventureWorks database. So I thought it was a good one to use because there's a ton of resources out there for it. It's super standardized. It's highly normalized as far as data structure goes and architecture. So I thought it was a good learning base to use for this class, even though we're plugging it into Postgres. So, and speaking to that, I chose Postgres because we potentially, and I'm looking around the room, we've got people on different operating systems, so we've got different platforms. Probably people at different skill set levels, and Postgres was just very easy to install. It works on both platforms, so it wouldn't restrict somebody or have a barrier to entry for somebody to be able to come to class because it was too technically difficult to get something to work with to be able to have an interactive workshop. So continuing on, we're gonna talk about entity relationship diagrams just a little bit. We're not going to make any, but we're going to look at some just to kind of give you a visual sense of a relational database, which is AdventureWorks is. We're going to talk about selects, using a couple of different functions and conditions and things of that nature to pull data out of the database that you may be asked for some department to provide you some data to send an email out to a set of users, or to identify which customers ordered X product at Y amount, or things like that. We're going to talk about joins. Today we're keeping it super simple. We're just doing inner joins. Is anybody? We're just doing inner joins today because we wanted to keep some juicier content for next time, and then we're going to talk about views. So that's kind of today's agenda, and it's not super filled out. I don't have a solidly packed hour and a half because my intention was to make it collaborative and kind of organic and let you guys help drive what you want to learn instead of me just sitting up here trying to cram a bunch of SQL down your throat. So for next time, we're just going to recap, see if anybody has any questions. You know, things that, you know, they came across or didn't understand, you know, kind of get all regrouped and caught up. We're going to go into more joins. So we'll be talking about left joins, cross joins, full joins, self joins, all these things that, frankly, I think a lot of times are outliers, but, you know, we'll talk about them because it's good to know what they are. We're going to talk about indexes, what they are, you know, why you want them, what they do. We're going to talk about some functions, some stored procedures, and then we'll just do a discussion and wrap up. And if you guys have something going on tonight or an idea that, you know, you want to incorporate for next time, you know, I'm totally cool with that. If that, you know, is the direction you guys want to take this, I want to make it, you know, loose and collaborative, and, you know, make sure you guys get something out of this. So, all right. So we already did this, so we'll just move on. Everybody's installed and configured. Does everybody have PG admin open in their browser and ready to roll?
Yes.
Okay. Cool. So, this is kind of where I was having those little light bulb moments, like, hey, this is just like SSMS in Microsoft SQL Server. So we've got a layout here where, you know, we've got a browser. This in Microsoft is called an Object Explorer. It's essentially the server that you're connected to, you know, the instance of SQL that you're running, the databases in the instance, and then its child objects therein. Also, I have a tendency to just kind of just go and just get rolling. So if you have questions, just
How did you get that screen?
how did I get to it? This is just a screenshot actually, but if you go open PG admin.
Yeah, if you look at if you click on anything on the left-hand menu, that's all she did.
Thank you.
Oh, okay. That's what you mean. I was like, wait, what? All right, cool. Good. Thanks. Yeah, so maybe actually let's do it that way. Let's do it interactively, because I think that's kind of probably better. All right. So here under our browser, and everybody should have, I think the instructions were on Postgres 12. So everybody should have Postgres 12 underneath servers. So we just kind of collapse this and kind of start drilling in here together. So you're gonna have databases. And one thing I will say is there's going to be plenty of objects in here that I am not going to speak to, because I didn't want to make this a SQL administration workshop. I wanted to make it more like learning SQL, the language, learning the concepts, learning how it plugs into applications, and not so much the administrator hat. Yeah, so there are some things I'm just going to kind of ignore. So for me, I've already created the AdventureWorks database, so I already have it here. You may not. So, you know, I did say, you know, if you felt like creating it, you know, you could go ahead and do that. Did anybody already create it?
No.
Not yet?
No.
Awesome. All right, let's do it. All right, cool.
You did the bare minimum.
Bare minimum to get here.
It has my laptop, it has the software, I have to be.
All right, so I wrote these instructions a couple weeks ago, and I know they're solid because I've tested them on a few laptops and had a few people test them. So I'm actually just going to open it up and reference it. So we have, everybody's got Postgres installed. Did everybody download the data zip file and put it into either C data or users data?
I
couldn't put it in. I couldn't have that. I have program data, but not C data. Oh, okay. So in that case, what you want to do is just create a directory on the root of C called data.
Okay.
The reason for that is the script is going to reference that location when we go to populate the database. So if you don't have that and the zip files aren't in that spot, then it's going to have an error and say, I can't find these files.
Okay.
So yeah, just C data and then just drop them all in there.
Where does it need to be?
Windows or Mac data?
Windows.
Yeah, just create a folder on the C drive called data.
Okay, thank you.
Yeah. Sure. And then yeah, all those CSV files should just be directly in there. So no subfolders, no like seed data. What I mean is
If you just extract the contents of what you download, it'll already be named data. So you can just drag and drop it into your C drive.
Yep, you can do that too. Yes. So it should look like. So for Windows, you should just have all of the CSV files there. For Mac, I mean, you're going to be looking at the same thing, but it's going to be under your users folder, under another folder called data. So.
And if anyone needs help, just let me know. I can go. Okay, cool.
We're around all day.
We're gonna jump back to the presentation real quick and do a create of the database because there we go.
Oh, I think she's going through it. Okay.
That should I can do.
And Emily, I'll answer that question here in just a second. Okay. Okay. So what we're gonna do is we're gonna create the database. Open this up full screen. We're going to create the database in PG admin because I want you to just, again, muscle memory, go through the motions, we'll create a database. So you kind of see how it's done and you can look at the properties and things like that. So what we're going to do is in PG admin, under databases, it's super simple. And that's one of the things I want to point out about a lot of the stuff that we're doing. It's super simple. Not everybody, oftentimes there's a seriousness about databases and like an intimidation factor, like, oh, I can't figure this out, this is too complicated, or I'm going to break something. You're not going to break something. Watch how easy this is.
We didn't do this way.
What?
Everyone at my work goes, we don't do it this way.
Yeah.
You tell them to just.
Yeah, I mean, there's that out there.
Calm down,
That's
finish
more
the job.
All right, so you're just going to right click, create database. And then, boom, you're a DB admin. So you can call your database whatever you want. We're not going to use it again for this class, so there's no certain name that has to be called or way it has to be set up or anything like that. Often what I do as a developer though is I just have like a Liz database because then I can find it, over here in the browser area because at work I've got many databases, right? So it's just nice and easy to go to the Liz database, and that's oftentimes where when I'm learning a new concept or trying to figure out a problem, I'll create tables and whatever other objects I need in the Liz database and populate some data in there and then start playing with it to try to figure it out, to solve a problem that I can then apply to my actual business problem without, messing up the data in production. So anyway,
What does the owner mean?
So the owner is a little bit on the DB admin side. It's just it's the owner. In this case, it's Postgres. Oftentimes in Microsoft SQL, it's the SQL Server service. So you can change it, but then you get into a lot of scenarios where you're going to have permission issues with people querying data or applications accessing data, and so oftentimes it's best to leave it at the default unless you know what you're doing and customizing it that way for a reason.
Okay.
Yeah. So in this case, the Postgres SQL service that is running on your laptop owns the database, which is what you want because then it can access all the facets of the data and the service to be able to do whatever you might want to do.
Okay.
So anyway, as soon as you hit save, you have a database.
Wow.
It's that easy.
Amazing.
So this interface looks a little bit different than Microsoft SQL Server. So again, there's going to be some things that I don't know. I'm not going to speak to them, but we'll kind of go over the things that are common between both of them and I think are at the appropriate level for what we're trying to accomplish in this workshop. So the way that it is structured is underneath your database, you're going to have a schema.
Is there any way to like enlarge at least the?
Yep.
Thank
Yeah, I actually had it. There we go.
Oh.
I actually had it shrunk down because I was trying to fit more on my screen. But what we can do though is this, which will get us a little bit more room. Is that good for everybody? All right. So does anybody know what a schema is, or have questions? All right.
Like a framework?
Kind of. So yeah, a schema is
Data relates to
it's a
each other.
yeah, it's like I think about it like a container, and oftentimes the schema is a container to organize data in a place, usually by business content. Like maybe you separate your HR stuff from your sales stuff, and so you got an HR schema and a sales schema, which is actually the case in AdventureWorks. So we'll see that here in a minute. A lot of times in the real world, the schema is just the default, which is DBO. So you may have seen that out there in some of your coding adventures. So the schema is a container. It's also not only for organization and structure, but it also can be used for permissioning. So you can naturally, you can grant permissions all the way down to like the column level of a table, inside of a schema, inside of a database, and so on. But oftentimes, the schema can be used to say, okay, like the sales team can only access the sales schema. And, the production team can only access the production schema. I've only worked in one environment where they had their permissions that granular. In most cases, it's DBO, which is the default, and anybody who can access the database, however the permissions are set up, can access all the things in there. So if we expand schemas on our test database, whatever you choose to call it, then you'll see that there is a public schema, which again, that's the default. I think that's the Postgres equivalent of DBO. And like I mentioned, there's gonna be a lot of objects in here that I personally don't know a whole lot about, and I think we would be getting into some administration stuff that is not our intention. So where we're gonna focus our attention is underneath today tables and views. So I clicked the little arrow to expand it, and nothing happened because I haven't created any tables yet. There's no tables in my database. So what we're going to do is we're going to create one, and we're going to do that by hand. Again, just to see. These exercises are kind of to show the value of what we're going to get out of running our script here in a minute. So what you need to be able to write a SQL query is a query editor of some kind. In Postgres, that's found under Tools and Query Tool. So when this query tool opens up, at the top you have your editor. That's where you're going to be entering your code. And then at the bottom is your results pane. Postgres has a few more options than SQL Server. The one that we're going to be looking at the most, though, is the data output. So that's going to, when we select data, it's going to show us our data. And I think that's where the error messages showed up as well. So, all right, so I'm going to leave this up on the screen. And again, this is the only part where we're just going to do something that's kind of pretty structured. What we're doing is we are writing a SQL statement to create a table in our database. And you're going to be doing this inside of your query tool. And if you're, feeling, experimental, or you are like, this is easy, or you want to do something different, feel free to create whatever table you want to create. The whole point of this exercise is just to go through the motions of creating a table so you can see how easy it is. While you guys are typing it out, just kind of speak to a couple of things. So the structure of creating a table is the command create table, followed by our table name. In parens are your columns. And the name of your the name of your column is the first string piece of text, and the data type is the next piece. So you're creating the structure of your table here in code. These are again a little bit different than Microsoft's data types, but I think, if you work in both worlds, or if you learn it this way for Postgres, it's going to very easily translate to other flavors of SQL. Can you see? You good?
Good.
Okay. So, for instance, Microsoft SQL has a data type. They don't have I don't think they have a text data type. If they do, I've never used it. Typically, it's. Yeah, sure. Yeah, I am tall and I have long arms. All right, so. Oh, it doesn't go on there. Oh, bummer.
Okay. Does that work?
No, it's not on TV.
Oh,
Sorry.
Hold on, let's
try. Actually, I sent it over here because I think it might be easier for everybody. So what I was saying was, I don't know that Microsoft has a text data type. Theirs is a bar card, and then you specify the length that you want your bar card to be. But in Postgres, apparently it's text. All right, so I don't hear typing anymore. Everybody's got it all typed out again. Yeah. Okay, so we're gonna flip back. And
What was the last one after your location?
go for it. Integer. Location is an integer, and then you've got the hire date and date. So another thing I'll point out. So if you're a developer, it's a very contentious topic, I think. Of do it the right way, or do it my way, or do it the lazy way, or just do it the way that it works.
I know exactly what you're about to say.
So another nice reason to kind of learn on Postgres is actually very standardized. It uses ANSI SQL, so it's just like the basic vanilla translatable SQL to all flavors of SQL. And one of the things I want to point out is it's ending in a semicolon. That's not required in Microsoft SQL. You can execute the statement without it, but it's a good practice to do it in ANSI SQL so that kind of dotting the I's and crossing the T's and making sure your code is clean and transferable and things like that. So, all right. So I do not have it written out, and so I'm not going to execute it, but I'm going to let you guys do it. So to execute your SQL code, you can do it one of two ways. You can highlight your syntax, your code that you created. And this is selectively running just what you highlight. So if I have a bunch of stuff in here, create this table, create that table, and insert this record and delete that record, if I highlight just the section to create table A, and I go to execute it, it's only going to do that piece. If you don't, if I had multiple create statements in this query window and I executed it, it's going to do all the things. So it's a good thing to know. There's a keyboard shortcut to execute, which is F5. Don't know what that is on the Mac. Is it F5? Okay, thanks. And then otherwise, you have a button here, which is the little lightning bolt, which does the same thing. So once you execute the code, you're gonna create your employee table or whatever other named table you decided to make.
Good.
So do that. So when you do that, that's where it goes. Okay. Under the messages area, it's going to let you know what happened when that SQL was run. So this is also where, if this is your first foray into coding, This is also where all of your error messages are going to go. That, you know, are going to tell you that you did it wrong, that you're going to be Googling to figure out, well, how do I fix it? So we didn't select anything, so we don't have any data output because we just created something. So now that we've done that, we've gotten our fingers on the keys and we've done a few things and we've, you know, clicked around the interface, and nobody wants to spend time creating an entire business's database in this workshop, which is why I put together the script. So if this is your first foray into this, there we go. I wanted to kind of, we're gonna run the script that I had provided in the class materials. The script references that data, all of those CSV files that are in that data folder. And when it'll create the database and all of the views and the keys and the constraints and all of the things in the database. And then it's going to reference the CSV files and pull all the data into the database and load the entire thing. So that's certainly a modifiable thing. We're going to take a look at just a bit of the script before we run it, because I didn't want to just have everybody run a script and go, ta-da, you have a database, and you don't really know anything about what you did. So, and also, let me just pause, because kind of just keep talking. Everybody good? Does anybody have any questions? And also, I should say, that's not my script. I didn't create it. I went somewhere on the web and looked for it, you know, downloaded it, and all that good stuff. I think I left the credits in the script as to who it belonged to. But it's representative of what we just did, but kind of more fully formed than you would normally do. And it has a lot of components in here that are good SQL concepts to speak to. So I thought I'd just kind of cherry pick this out, and we'll kind of talk about it a little bit before we actually run the script. So when it runs, you'll know what's happening. Yeah, and this is also a good opportunity to ask questions, learn some things about SQL if you didn't already know them. So kind of like we just did, this block here is going to create a table called the person table. These two lines here are they're going to reference the CSV file for person, and it's going to copy into the person table from that person CSV file. So that's how your table is getting populated. It's one way to do it. There's lots of ways to populate tables, but this is one way, good way for a class like this. So, and these last four lines are adding a primary key to our person table, and then also putting an index on the primary key. So that's kind of like at a high level what's happening. I dropped this into Notepad++ and set the language to SQL, so it just kind of, that's where the color is coming from, but it's good to kind of show some of like the reserved words and reserved like SQL syntax words. They're showing up in green, the alter table, constraint, using, those kind of things. One of the things I'll point out is the null not null. So that's specifying whether or not that column is allowed to be null or allowed to not have a value in it or not. This is important because for a couple reasons. This table's primary key is the business entity ID, and if that's your primary key, it's kind of like the social security number of that record. Every record is unique. It has its own number that's different from every other record in the table, and you have to have one. You can't have a record without a primary key value. So we don't want to allow it to be null. It is not null. On the other hand, the person type, the title can be null. Maybe the person doesn't have a title. So there is still a column there, and we can or cannot populate something into the title column, but we don't have to. And you know, the table, the constraint, there's not a constraint on the table to force us to put something in there. So that's what's going on when you see null or not null. We see things like constraints. So these, they can be different things, but I'll speak to what we have here in this context. This constraint is on the name style, and it's forcing the name style default value to be false. So I'm not, familiar with the data. I don't know what the name style is, but by default, every time you put a record in there, the name style is always set to false. Same thing here with the email promotion. The default is 0, which probably means off or no. This is a different kind of constraint. I've never coded one of these, but I can tell what it's doing. There's a constraint to force that the email promotion has to be between 0 and 2. So if I try to insert a record to say, oh, I want the email promotion value to be 3, it's going to just throw up everywhere and give you all kinds of errors because it doesn't, it only allows 0, 1, and 2, and that's it. Here it's using a function, the upper function. So when we go to insert a person type, and if it's in, I'm trying to think what these are. These are, okay, so maybe like employee, intern, something like that. But it's forcing it to be upper. So that's probably to standardize the data, so when they pull the data back out, it's already uppercase. Yeah. So then we also see, like I mentioned, setting up the primary key, which is a constraint. It forces that column to not allow nulls. One thing that's not on here, a lot of times when you set something as a primary key, you have the option to set it as an identity value. So that's where it starts at a value that you define. Usually it's 1, and it increments by a number. Usually it's 1. So in other words, you start at 1, go 2, 3, 4, and so on. But it sets that by default. So every time you insert a record, that value is set in the primary key column by default. And the logic in the SQL Server knows, hey, the last value was 364, so if I'm inserting another record, the ID is this one is going to be 365. And that just happens automatically behind the scenes when you set an identity value. So. Does anybody have any questions or want to talk about this anymore before we run our script? Yes?
The delimiter E / T, is that making the separated comma separate into a tab? What does the delimiter mean?
Good question. I don't know, but that's probably, okay, so the delimit, okay. So we're loading data from a CSV file, so essentially an Excel file. So a lot of times when you're doing data integration and you're trying to, like load some data in from somewhere, and a lot of times with Excel files, you have to specify what's your delimiter, meaning SQL Server is like, tell me what means the end of this piece of data that is going to go into a column. And here's where it can get tricky. So CSV is a comma separated value, right? What if your string has a comma in it? What if your string is love, comma, Liz, and it's the person's name, right? So you have to set a delimiter value, and that's probably what's happening here. You have to set a delimiter value to tell SQL Server this is the end of this string, that this piece of data that goes into this column. Because if I didn't tell it that, then it would split up love and try to put it in this column where name is supposed to go. That should have my last name, first name, and it'll take Liz and put it in the next column, which maybe that's ID, right? So it pushes all the data forward one column. It creates a problem where you got to back all the data out and set a delimiter, and then you have to push the data back in to get it to go into the right place. Does that make sense? Yeah?
Is it always gonna be \t?
No. I mean, you can make it whatever you want.
Oh.
Yeah. So the person who wrote this script just
Okay,
chose to
okay.
use \t.
Okay.
But you can, another common one that besides a comma is a semicolon. But that can be tricky sometimes too. So one that is even better than that, in my experience, exactly the pipe. Yeah. All right, you guys ready to run scripts? There's two ways to skin that cat. You can put a line, create database in the script if you want to, or you can, maybe you already did, create your database as AdventureWorks, or you could just create another one, call it AdventureWorks. Let me get out of presentation mode and I'll put it up.
So from where do we start copying these over? The script.
Yeah, good point. Totally getting ahead of myself. Okay, so yes, Lori's right. So what I failed to mention was you're going to have to put all this into our query tool, right? So since it doesn't have the create statement, if you want to, you can just do it right here.
That's if you haven't already done it.
Yeah. Yeah. If when we did right click create database and you called it AdventureWorks, you're already set. You're going to go over to Postgres. So this folder icon here. Okay. Lets you browse to wherever you saved the script at. So I gotta go find it for myself. But in the interest of making sure that the most people can get the most out of the time that we're here, I'm going to keep moving forward. So essentially what this script did on a large scale basis is a whole lot of creating a table, copying data into the table, setting some attributes on the table for an entire database. What that database looks like is this. And don't hold my feet to the fire because I don't know what version of AdventureWorks the script was built on. It could have been 2012 or this diagram is specifically the 2008 version of AdventureWorks, but not a lot changes between the versions except for when Microsoft adds a new feature, then they're going to put that into the sample database. But I wanted to show this so that you guys can kind of get an idea of what a database looks like from a relational perspective, instead of just like a screen full of code and show me the orders and what's so and so's phone number and things like that. We're not going to go into this in too much detail, but I want to point out I thought this was useful because it had color coding. Each of the colors represents a different schema. So they're color coded over there. We've got human resources schema, the person schema, purchasing, production, and sales up here. And you can see the lines and the arrows in between them, which indicate the relationships between the tables and on what column in this table is relating to what column in that table. So we see some of the, we didn't actually see in the code, but there are another constraint that can be created is a foreign key relationship, meaning, the primary key in this table it actually is in this other table over here, and over here it's called a foreign key because that's what ties those two tables together in a relationship and allows you to pull something from this table and something from this table and put them together, and they're still talking about the same thing. And what I also wanted to do is, because I thought that was super huge and kind of overwhelming, just look at one schema. So, you know, font's a little bit larger, and we kind of see some things. You know, we've got a products table. You know, there's a transaction history, and there's a product ID here that ties in where it's got to be in here somewhere. Product ID on this table. Similarly, you know, you've got product inventory. So, you know, it's going to tell you what your counts are, what shelf it's on in the warehouse, things like that. If you want to know more about it, you know, you can go to the product table, so on and so forth. I don't want to overkill this because it's very heavy. But does anybody have any questions? So this is what's referred to as an entity relationship diagram. So it's a visualization of all that code and all those relationships in the code.
When you create a database, do you always make one of these?
I don't, but I really like them. And when I was thinking about how to put this class together, I'm a really visual person, and so it is really hard for me to conceptualize sometimes when I'm thinking about something in a virtual space or just something that's just in thousands of lines of code. And, you know, if I wrote a query and I got 10,000 records back, what does it even mean? You know, I really connect the dots in my mind much better when I have something visual to work off of. So that's kind of why I wanted to show this, because you know, not everybody's a visual learner or thinker, but some people are. So you know, I thought some people could find some value in it. So anyway, if you Google, you can find tons of information about entity relationship diagrams. You can find tons of tools on how to make them. And if you're interested in getting into databases, it's kind of an important thing to know about. So, you know, we got a database that we created last time that we're working in. If you don't have it already set up, you know, feel free to follow along, because I think it's fairly straightforward to set up, and you can, if you want hands-on, you can do that at home, and all of the files are available on Dropbox. If you RSVP'd before like 2 or 3 o'clock, I had sent out an email with that link, but if you didn't get the email or you want the link, just let me know and I can get that to you. So what we have, just to kind of recap, is we have, you know, we're teaching SQL in Postgres, and that decision is because we can support both Mac users and Windows users relatively easily, so we can, you know, accommodate more people. What I did, I come from the Microsoft SQL world, and so what I did, you know, kind of for my own benefit, is found an AdventureWorks database, which is their sample database, and found a script to get it into Postgres so that we can use that as our playground. So we have examples to look at. We've got tables we can query, things that we can do in this database, and yeah. So last time we kind of ran out of time. This time I created like a kind of like a timeline, an agenda, so we can get through as much as possible, and you know, kind of keep it moving, and then you know, maybe leave questions for the end. You know, we can play it by ear. You know, there's no hard structure here. I did want to ask, does anybody who was here last time that may have had a question that didn't get answered to this point, do they have any questions that you want to ask? Or should we just jump in? Jumping in. All right. So last time we just kind of briefly left off with the concept of select, which is to essentially ask the database for some information. And that's done via a select statement. And there's a couple of different concepts in a select that I wanted to cover that I think are useful. Not by no means is it all of the concepts, but at least kind of wet your feet and give you an idea of what's possible. So if you haven't already, go ahead and bring up PG admin, and I did mention that I sent out the email that had some updated files for class tonight. You know, you can go access that and pull that down now if you haven't already. it's not gonna, if you don't have it already, it's not gonna impede you from learning, but it just makes your life easier because you've already got everything written out and you don't have to type it out yourself. So just kind of give you guys a second to kind of get there if you need some time. Bless you.
How do I pull the script in?
So you downloaded it, right?
Mm-hmm.
Okay.
I put it in the folder called data.
Oh, okay. All right, cool. So then what you're going to do is you have to have a query window already open in Postgres. If you don't have one, just tools, query tool.
Okay.
And that will open, here, we'll just do it again here. That will open a blank window like this, and then you're going to open a file. This right here. I wonder, you know what I wonder if...
Okay, open file.
Yeah, we'll just do that. Open file, which should give you a file browser.
Okay.
And then you just need to browse to the data folder.
Okay.
And when you find it, you're just going to select it and then, or highlight it to select it and then select.
Okay. Thank you.
Mm-hmm. All right, so we're going over select. So, again, just to kind of do some basic things. On my slide there, I mentioned the first bullet point is star versus certain columns. So, if you select star from a table, then you're selecting all columns and all data, for that matter. Otherwise, you can select this column, that column from the table, and you'll just get back those particular columns which you have specified. There's certain cases where you'd want to do one versus the other. Kind of talked about this a little bit before. Select star is not. If I think we talked about this last time, but I'll just kind of mention it now. So if you have the script open, you want to run something, you're going to highlight what you want to run, because this script has a whole lot of stuff in here. So you're just going to highlight what you want to run. You can hit F5 on your keyboard, or you can hit the little lightning bolt here, which is execute. So you can execute that code, it'll run the query and return the results. So this is a select star. So we are getting all of the columns. This table has 6 columns. And I'm going to run it again because Postgres doesn't have a status window like I'm used to. So we have 19,820 records. And we're just getting everything. So you may want to do that to make your life easy, to just, you just know you're always going to get everything, or maybe you don't want to hard code columns because columns may change. But it can also be non-performant, like you may want to select just certain columns, in which case, and actually let me kind of say this as I'm going along because I'm going kind of fast. I have, if you're not familiar with the concept of commenting, basically every language has a way to comment out on some code so that when you go to execute a block of code, that particular thing does not run. In Postgres, it is the 2 dashes. And I've kind of I also call out in this file, I've made notes all throughout here as to like what is this block of code doing, like, or maybe some kind of little added comment to explain a certain thing. You'll see more of that as we go through. So what I did just now is I commented out the star because I don't want to select star anymore, and I removed the dashes in front of these columns. And then I'm going to highlight it again and run it, and then whoops. It never happens when I'm developing. It's hilarious. It's like, okay. Well, actually, so here, okay, this is an example of things that happen. So I think I know what the columns are. Clearly I don't, because I'm getting an error message. So let me go back and select star. And this will tell me what columns I have. And I know why this is in here. This is because I started this out doing a join. And then I changed my mind. Okay, so what we're gonna do is, so this is good because you guys got your hands on the keyboard. I'm gonna change this. I'm gonna get rid of the other stuff, and I'm just gonna say, all right, I'm just gonna select the customer and the person ID. So we'll uncomment that, comment out the star, and then now I'm only getting those 2 columns.
Are you able to make that bigger?
Yeah. Is that better? Yeah? Okay, cool. All right. So that's just your basic select, and that's the star versus certain columns. You may want to restrict the data that you're getting back. Maybe we don't want all 19,000 rows, right? Maybe we just want a couple of rows specifically for a certain thing. So our next example is showing how to do that. It's a where clause here highlighted. So I want to select these columns specifically from this table from the employee table, where the employee is a research and development engineer. So if I highlight this block of code, and I didn't make any errors, we're going to get 2 results. So that's the concept of a where. And that's useful because maybe your table has 10 million rows. And if you do a select star, that's going to blow up the performance on the server, and somebody may be angry with you. Or you may just be frustrated because this query is going to take a really long time to run, and you didn't really need that much anyway. So where clauses are, definitely useful in many cases. Different example of a where clause, we're going to select the person where their middle name is M. Some details about the person. So if I highlight it and F5, these are all the people in the person table who have a middle name of M, which is quite a few. There's a lot of people in this table. Another concept is like. So maybe I don't know exactly what the product name is, as highlighted here, but I kind of have an idea it's got a decal. Like it's some kind of decal, I don't know, decal, yada yada. So like presents the concept of, I know part of it, but I don't know the rest of it. And pretty much every language that I've had exposure to has this concept in it, where there's some wildcard character that you could specify to indicate like an unknown section of this string. So you specify part of it that you know, and you put the wildcard in there to indicate and anything else that follows this part that I know. You can alternatively switch it, and maybe it's something something decal. You would put the % in the front. So this is gonna have an error. It's something that actually it's gonna return nothing. This is something that I ran into. I knew that there were records with a decal, and I have been coding long enough in another language where it wasn't case sensitive that I was not coding in uppercase, and I don't need to in Microsoft SQL. Well, apparently I did need to in Postgres because I was getting no results, and then now when I have a capital decal, I got 2 results. So just kind of little nuances, little things to be aware of, so they don't become stumbling blocks for you. Just every language has their nuances. Okay, so another concept in select is distinct. So it's kind of like unique. So the 2 examples that I have here are, we're gonna get all the last names from the person table. So I'm gonna highlight that line and F5 it. And I've got 19,000, almost 20,000 people in here, right? Well, some of these names are gonna occur more than once, and I probably won't be lucky enough to, have that occur naturally because I didn't order it. So, but I know that there's gonna be some duplicates. There's gonna be more than one Smith in there, more than one Jones in there, so on and so forth. So if I select the distinct last name, that's only give me 1 result. Even if there's 20 Smiths, only give me 1 result of Smith. So it's distinct. So when we run that, we get much fewer results, 1,200. So there's a lot of duplicates in this table. So that can be a tool that you can use when exploring data, just kind of get a sense of what's in the table. All right, a little bit of, a where clause with a date. So I'm going to do a select star from the product cost history for any record that's been modified on May 16th of 2013. And I'm not going to kind of go through and edit my script here, but I did put examples in here for you guys that you can kind of play around with. Like maybe you want it to be greater than May 16th, or greater than or equal to. So you include May 16th and everything greater than. Another concept, and I didn't do the research ahead of time to know if it's Postgres, written this way in Postgres. So you may have to Google it if it doesn't work, but there's a concept of between. So you can say,
You can do Postgres.
you can? Okay, cool. So you do have to write the date like an integer, so in other words, 2013-05-16, no dashes. But anyway, those are just kind of some things for you guys to play around with. You can see what's going on in the product cost history table. This concept is used all the time. If you're working in data, people want to know, what happened last month, what happened last year, what happened in this month, who got hired, who got terminated, what did we sell, who got promoted. All of these kind of things are date-based things, so it's very important to whatever language you're working in, if it is Postgres or Microsoft or Oracle or whatever, to know how to use the date modifiers and a where clause. It's very powerful. All right, so we're gonna move back to the slides. I don't know how I'm doing on time, let's see. Hey, we're right on time, awesome. All right, this is promising. Okay, so another concept that I wanted to introduce is functions. If you have any programming background, this is not news to you. If you don't, just to kind of explain it, following kind of like the what, why methodology. What is a function? It's a little bit of code that you've written up and you've saved it. You can pass it a parameter and it'll return you a result, which could be a single record or it could be a whole table full of records, and it just runs a select. That's it. That's all it does. So I'm making that distinction because later on we're going to talk about stored procedures and they're a little bit different. Why do you want to use a function? It complements and enhances your select statements to manipulate your data to suit your needs. On the left side, underneath the word functions, are some examples of some built-in functions, and we'll kind of talk about those when we flip back over to Postgres. But those are the built-in ones. You can definitely create your own functions, and we'll look at an example of that next. Excuse me. So this is just something that I screen capped from somewhere, so I'm going to kind of talk through it a little bit so you kind of see. And then below is the example of how you would actually use it. So in other words, what's in the box, I scripted that out. Like this object already exists, and so this is the code to create the object. The object is going to get the purchase order status. So if you can think about a table that has a bunch of purchase orders in it, there's a status column in this table, and in that table, or in that column, it's just a bunch of numbers. So if you're selecting it, like maybe you're going to build a report, right? Like you want to, bless you, you want to provide the sales order management team status on their purchase orders, right? They need a report, and they have to have this information in the report. Well, the word or the number 1 is not going to help them, So what this function does is every time there's a 1, instead of selecting 1, it selects the word pending. And 2, it selects the word approved, and so on down this list, right? So this is, like I said, I've seen a little bit of furrow brows. This is abstract. We're not going to execute this example. I just kind of want to talk through it. And we are going to execute another example, and I have a third example to show you at the end. So if we think about selecting status from purchase order, let's say I got 10,000 rows. Well, I'm going to get back, a status column because I'm specifying just status, and it's just going to be full of numbers. So that's not very helpful. So what this function does, if I say select and I'm calling out specifically the function and passing in the status parameter, then it goes and reads the status column, and every time there's a 1, returns pending, and every time 2, approved, and so on. Now, of course, you would select more columns, like maybe who's the customer, and what's the date of the purchase order, and maybe who's the salesperson, and then the status, right?
So is this updating it in the database, or is it just updating it in your temp file?
It's virtual, and it's just in your result set.
Okay.
Yeah. So yeah, that's a good point. So if it's not a table, in other words, if it's a view or the result of a query, or whatever a function selects, those are all virtual objects and they don't physically exist on disk. They're all in the temp DB in memory. Yeah. All right. So that's enough talking. Let's kind of switch back. We'll switch back to Postgres. And so kind of broken up here, just cruising on through. I've told you that we would talk about what those built-in functions do. I'm not going to read through all of them. You're going to see some of them later. Basically, it's just a brief explanation, in my words, of what that thing, what that particular function does. And, if you're not familiar with programming, basically inside those parentheses, that's where you're going to pass in parameters. Some of them require parameters, some of them don't. So it just kind of depends. And then, well, some functions, I should say. These all require them. Okay. If anybody is interested in later on when they're playing around with it, with the date diff and the date part, those are specifically written that way to accomplish these things in Microsoft SQL, and they're a little bit different in Postgres. So if this is like, I have a date and another date, and I want to know what, how many days transpired in between this beginning and this end of this thing, whatever it is. That's what a date diff does. And a date part is like, well, I have December 4th, 2019, and I just want the day. So that it pulls out just the day from that date. So I did create a super duper basic one because I had a lot of stuff to build for this. So you can actually run this and you'll end up creating this function in your AdventureWorks database. You can just highlight it and run it. What you're gonna get is you're gonna have a function that is created. It gets created in the, if I remember correctly, in the public schema. It's distracting. Under, yep, there it is. And what it does is the function's name is getSum. It accepts 2 numbers, and then what it does is it adds up those 2 numbers. So super basic, but it kind of illustrates the concept. So you're going to select the function name and you're going to pass it the parameters that it expects. I think if this doesn't say that they can be null, so I should get an error. Yeah. So if I took out my parameters, I passed it no parameters, you're going to get an error message. If I pass it 1, it should still show an error. Yeah, because it's expecting 2. So let's, just, I don't know, something. Oops. There. So it's just going to add the numbers up. I didn't want to spend tons of time on functions, but I did want to talk about them because they come up from time to time. People could be wondering what they are, how do you use them, when do you use them, what's the difference between a functionist or procedure, just kind of some of these high-level questions. So it's not as important, I think, though, as the rest of the content. So we'll keep on rolling. How's everybody doing so far? Good? Cool. Okay, so so we did touch briefly, I believe, last time on joins. I'm going to show a few slides, and then basically the bulk of a lot of the rest of our time is going to be spent on playing around with joins and selecting data and kind of, I got some queries in here, but, we can definitely change them, play around with them. So we'll do that for a little while. But we're going to talk about them first. So, yeah, because everything you need is never all in one table. Life is not that simple. So, you can select some data from table 1, and I have an example of this, but dang, this other thing that I need is in table 2. But I need just those things. So we join. So there are many kinds of joins, and since, we kind of have a limited amount of time, I've decided we're going to kind of talk about 2 of the most commonly used join types, and then I'll kind of show a couple of others, but mostly we're going to hang out with inner joins, or you may see this written as just join, and then left joins, which this example shows them as a left outer join, but most commonly it's written as left join. So I like these, and even on some of like the lesser, used joins where I don't use them that much. And in my mind, I'm visual, so it's always good to kind of have the Venn diagram. What am I getting here? So inner joins are pretty simple. They have to, the data that you are looking for has to exist. The primary key or the join column that you're joining on has to exist in both tables. And when it does, you're going to get a result, which is in the green. And then I thought, well, just for fun, because mostly in actual real life, you're lucky if you're only interjoining two tables. So I just decided to kind of throw in here an example of more interjoins. So if the more tables you throw in there, every time there's an inner join, it essentially has the potential to reduce your result set, because everything has to exist in all the tables in order, or, the data has to exist in all the tables in order for it to be returned, which usually there's some kind of disqualifying factor that, ends up dropping things out and gives you a smaller result set. And don't feel like you have to memorize this stuff now. I sent out the slides, and then, we got some examples. And I also sent out the PDF from which I took these screenshots, so you can use it like as reference later. I find it to be a really useful tool. I still use it. So, left joins. Left joins. Basically, you start with a table on the left. Table 1 in this case. And then you're going to join it to another table on the key. They have it written here as left outer join. I always write it as left join. It operates the same way. And really what you're doing is you're getting all the data in the table on the left. And any table that also exists, or any data that also exists in the table on the right. So, we'll look at some examples of this later. But I think it was important to just kind of see the visual, ahead of time. And I threw in also the two left outer or left joins, because this is going to show up a lot in the production example I'm going to show you guys later. Because a lot of this stuff that we're doing is rather simple, right? We're going to select some stuff, we're going to join a few simple tables, and so we want to make it digestible for everybody in like a really condensed time period. But in real life, things get really complicated, really fast. And I hang out a lot in left join, like inner join a couple things, and left join some subselects. And so it's good to have a visual of like what is that doing. So there's also a right join. I don't know too many people who use right joins, because it's really the same concept, except for it's on the other side. And usually most shops I've ever been in to do a left join. So you're just going to start with, you're going to position your tables such that, I want the data from here, and then, left join some stuff to it from other tables. So just wanted to mention that, because when you start looking at joins, you're going to see right joins out there and may wonder, why didn't we talk about right joins? It's just the same thing in opposite. And also, if you're in a group who's coding together, and everybody's using left joins, it's really confusing if you decide suddenly you're going to use right joins. So kind of as a group, you make a decision together, this is what we're doing. So we're going to practice with inner joins and left joins here in a minute for a little while, but I wanted to mention these other types of joins that come up commonly. We're not going to talk about them in here, we're not going to practice them in here, but they happen a lot. So the top left there, you got your inner join and a left join. I'll show you an example of this later. Top right is a cross apply, which is essentially taking a table and then interjoining it over to a result set from some kind of query. So it's not actually a table, kind of getting to is it stored in the database or is it in memory? It's joining stored in database to some result set in memory. That's a cross apply. I got this question when I did the beginning class, and also people just seem curious about this. It's kind of interesting, and I've used it once. so I thought I'd mention it. It's a kind of an outlier. The Cartesian product. So that's a cross join. So you take everything in this table and you join it to everything in this table. So the results are
Huge.
this times this many records. So you got 10 here, you got 10 here, your results are 100. Yeah. So the only time that I ever did this is actually this year. We were implementing schedules for international work schedules, and we needed to have a representation of every possible geo and every possible day, and then give it an indicator as to whether or not that was a work day. Because we were bringing on an international office, and they had different holidays than we have. So we had to have an indicator for who's got a holiday, who doesn't. So how do you do that? You join it to itself, and then you get this Cartesian product. But like I said, I've used it once. But people ask about it a lot. This other last one here gets used a lot. It's a union. It's basically saying, hey, I got this set of data and union it to this set of data. And it's kind of like tacking it on. Like I got 10, I'm selecting some stuff here, I got 10 records, selecting some stuff here, I got 20 records. So now it's a list of 30 records. The thing with unions is you have to have the same columns, or the same. It might. Usually when I'm doing it, I'm trying to get the same thing, but it's coming from two different places, so it kind of usually is already the same data type. So an example would be, we used to have a different system to manage all of our scheduling and time and attendance and all that stuff, right? So up until a point in time, we had to select from the old database. And then once we cut over, now we're selecting from the new database. And in the reporting tool, it doesn't really care where it came from. It just wants a list of the things, right? Regardless. So we're going to union them together, and generally the name is going to be a text, and it's going to be a text, and the date will be a date, So it sort of naturally lends itself to being the same data type anyway, in the use case. All right, so we are going to hang out and do some join practice. So I spent a lot of time kind of prepping some scripts here. We can definitely go off script, but what I was trying to do here is show some examples, and then also show kind of like some of it. I left it in here because it's kind of the process, and these are simple selects, where you're trying to look at one record to illustrate the concept, but this is stuff that I still do in production now. And again, I'll show you that later in my real world example at the end. So we want a list of employees. Okay, so setting up for the join. We want to get a list of employees at their hire dates, but the employees, some of their employee data is in one table and some of their employee data is in another table. So we're going to have to join. But in order to figure out how to join, you can kind of, I'll bring it back out here. You can kind of scroll through, and it's a good idea to your Object Explorer or your browser, as it's called in Postgres, and just look around and be like, all right, what kind of tables do I have? Okay, I got an employee table. What kind of columns does it have? All right, we got, we have these columns. Anything that has the word ID at the end, probably going to be a primary key, probably going to show up in other tables and be a column that you're going to join on. So that's one way of doing it. You just got to visually inspect the table. Oftentimes I'm dealing with big tables and lots of systems and things I'm not familiar with yet. So usually I'm gonna select some data and just kind of see what's in there. So that's kind of how I started this. I'm like, okay, I want a list. I was just trying to make up an example. I want a list of employees and some other piece of data that's not in that table, so we can look at a join. So I was like, all right, what's in person? So, and then I just randomly picked the name Bradley. so we got some Bradleys in here. We got a lot of Bradleys in here, and I want to point this out because it's going to be important later. There's a person type column in here. I don't know what all of the values stand for, but we got one that is an employee. This guy here. So I said, okay, all right. So I got Bradley, and I noted that Bradley's ID is 16. So I said, okay, well, then what do we have in the employee table for this ID? At first I did try, like, you know, what's in the employee table? Can I do the name? Oh, there's no name in here. You know, so that's kind of how I got to this point. Like, I'm gonna have to make a join here. So, you know, what do we have for this guy, and what can we use? Okay, there's the birth date. If we were interested in hire date or any of these other things, you know, we could bring those in as well. But that at least gives us the relationship. You know, we know, okay, let's select that. We know that we have a business entity ID in this table, and we also had it in the person table, so that's going to be my join key. Scrunch this back down again. When I do that, it always makes me scroll back to where I was. Okay, so I'm not going to talk about the pay history yet because we're going to talk about that in the next example. So we're just going to interjoin these. So introducing another concept here. So we're going to select some columns from the person table. We're going to join it to the human resources employee table on a key, which we just identified is the business entity ID, right? This concept here is aliasing. You may or may not be familiar with it. It's basically a shortcut, so I don't have to type as much later. So I don't want to have to type on my join. I don't have to type join on person dot business entity ID. That's just too much typing. So I'm just going to call person P. So then down here, when I'm joining, then it's just P dot business entity ID. So if you haven't run it already, you can highlight it and run it, and then you can see, okay, we got David Bradley here, and David was hired on December 20th, 2007. So he's been with the company for a while. So that's interesting, but kind of basic because it's just two tables, and in real life, this almost never happens. So usually we're going to have to get tricky and start adding in more tables. Because, you know, maybe we want to know more about Bradley. So I thought, okay, let's find out what does Bradley make. So we know in this result set we have one Bradley, right? There's one Bradley, and he was hired in 2007. So I kind of go, okay, you know, I went back up here, and I looked in, you know, and I purposely selected this guy to illustrate this example because it's something that comes up in data all the time. This guy has several pay histories because he's been with the company for a while, right? So he's, you know, been promoted, maybe changed departments, maybe he's a manager now. I don't know what's his story, but he's making more money than he was in 2007. So this is important because when I go down here to introduce that join to bring in his pay history, and actually I'm going to modify this right now. We're going to select also EPH dot, I think it's rate. So what's going to happen is, I got 3 Bradleys. So if I'm trying to report, maybe I need a report on who was hired and how much money, you know, they're making per hour now, right? We're going to do some reviews of department budgets or something. I don't know. Well, I can't tell the firm, hey, you got 3 Bradleys. There's only one Bradley, or one David. So we have duplicates. How do we get rid of the duplicates? So this is going to introduce another concept, another couple of concepts actually. I'm going to scrunch this down so we can see the whole thing. So we're going to join, you know, we're going to join multiple things together. We're going to join 3 things together, 4 actually. But we got to get rid of those duplicates. And so I'm going to kind of key in on this sub-select right here. I'll highlight it right now. I'm going to key in on this right now because this is our deduplicator. So what we're doing is we know that there's 3 David Bradleys, but we only care about the current David Bradley. So what I'm going to do is I'm going to use one of those built-in functions, the max function, to bring back the maximum modified record. because per my business rules, that's what says this is the most current record. I also want to bring back the business entity ID because I'm going to need that later to join on it. So for this sub-select, and we can run it independently by itself. So if you highlight it and run it, you're going to see that this is the most recent record. So this is useful information because now what we can do is we can say, okay, I know that the max record or the most current record is from April 16th, 2012. So I can take that record and join it back to the pay history to be able to pull the current rate out. Because otherwise I was getting all three because I was just joining on the business entity ID, which occurred 3 times. So we have essentially the same select as before. We're going to select from person, get the name piece. We're going to select from the employee table to get the hire date. And then we want that rate, which was in the employee pay history. And we deduplicated it with this sub-select right here. So when we run the whole thing, now what we're going to get is one record, which is David Bradley's most current record with his most current salary. This is a very common, it may not be names and pay rates, but it may be very common that you've got multiple records for a thing, and one of them's the winner. Whether it's the maximum, meaning the newest or the biggest, or the oldest or the smallest, whatever it is, you got to figure out which one is the one that you're after. Because if you bring back a report, that has 6,000 records in it, but you only have 2,000 employees, there's gonna be questions. So, right? So this is used very commonly. Yeah. All right. I can see that I didn't finish that, but oh well. All right. So that's inner joins, which means it's got to exist. The data has to exist in both tables in order to return the result. So we are only getting, just this small record or results records, not all of the records. To kind of show an example of a left join, where I want the things that exist on the first table and also just those that exist on the table on the right. That's where I'm going to use the left join. So in this case, in this one we're going to kind of play around with a little bit. So I'm going to run, and there's a lot of comments in here, but I'll talk through them so that, if this is new to you, that you kind of know what's going on here. So if I highlight and run all the way down to line 146, this is just my basic left join. So this is all the results. It's everything from the product table, all products, regardless if they were ordered or not. I'm going to uncomment the first where clause. And now I'm saying, okay, left join those tables together, but left join it where the sales ID is null. That means those products haven't been ordered because there's no sales ID for them. I'm still getting all the products, but just the ones that, have an order. Actually, do not have an order because there is no sales order ID. And you could see that, and I just kind of put in the comments here because Postgres flashes the result, the count, of records returned, and then it kind of goes away, which to me is kind of annoying because it doesn't do that. In Microsoft SQL, it's just statically there for reference. So I just kind of put those, that's kind of what these comments are here at the end. So we just have 238 results. If we we comment this line back out again, just kind of to make it easy to highlight the block and run it. If we want all the products where the sales ID is not null, in other words, there is a sales ID, these are the products that have been ordered. So it just kind of shows you the ways, a basic left join to start with, and then kind of ways you can modify it, this way or that way to sort of continue to narrow down to whatever your use case is, to what you're looking for. We're doing on time. 15 minutes left. All right. Okay. So I had a request to this is kind of from the beginning class and just kind of in discussion, like if we could make an example of like a report or something that the business is asking for. And this isn't my business, I'm not intimately familiar with this data, so I was kind of seeking a very basic example and kind of found one and put it together, so we're just gonna kind of go through that. So, basic example, we got a monthly company newsletter, you know, we want to send out, and part of that newsletter, you know, you probably see this at your place of employment, here's the people whose birthdays it is this month, or here's, you know, the anniversaries of so-and-so, you know, these employees have been here this long as of this month, or, you know, things like that, pretty common. But this is also, it's a simple example, and it's also a good example, because I think you can take this and really get the concept and then build on it and apply it to other areas that may be more financial related or performance related or things like that. So I did the same sort of discovery in trying to figure this out, because this is not my data. So, you know, I kind of poked around in the person table. I decided that the person with the last name of Laszlo was going to be the person that I was going to go for. You know, I'm just kind of bringing this up here to illustrate a concept or a point, which is there are 2 Laszlos. However, this is kind of what clued me into, you know, the fact that there are people in this table, and I'm not really sure what an SC is, but they're not an employee, right? And the point there is it kind of illustrates the whole inner join concept that we were looking at earlier, because we were interjoining between the person table and then the employee table. And before we were dealing with David Bradley, and there were tons of Bradleys in the person table, right? But there was only one Bradley in the employee table. So when we joined, you know, on the business entity ID, all those other ones fell out that aren't employees because they aren't in that table. So I thought that was a good point to illustrate. We can take a look at the employee table, kind of gives us, you know, if we're thinking about this, you know, monthly newsletter list, you know, I'm always looking first for what's the key. What am I going to join on? And conveniently, business entity ID occurs, you know, lots of these tables, but this table in particular happens to have the birth date and the job title. So I thought, okay, well, maybe, you know, we got this list of, you know, Mary Jones, and she's marketing, and her birthday's on, you know, December 1st. And then we got Bob Miller, and, you know, he's in sales, and, you know, that kind of thing. So I was trying to replicate what I see come through in my email. So that got me thinking, okay, then I need to go look for the department. How am I going to get the department? Because what's, you know, I start looking, well, what's, you know, and I just did a select star because these tables aren't super huge. So I was like, okay, I'll do a select star of what's in there. So I just ran just the select star piece. So, okay, well, you know, and I could, you know, just again point this out. You can definitely do this. You can browse in the browser and like look for this. Sometimes it's just easier to select star or select top 10 star, that kind of thing. So anyway, so the department, you know, where the name that I want out of the department table, it doesn't have a business entity ID. So I was like, all right, then I got to have some kind of table in between the people and the department to be able to connect these together to figure out what department, you know, Bob Miller's in. So that turned out to be, just kind of by poking around, the employee department history table. So it has the department ID and the business entity ID. So I was like, all right, now I can join my person in on this side, you know, and then segue through this department ID for this person over to the department table and get the name for that department. So I was like, okay, I'm onto something here. Now I could build like a select, you know, a join example. We can kind of, you know, select some stuff and figure it out. So gonna kind of just put this piece on the screen. So what I then thought was, okay, you know, we can select p.firstname, and it comes back as, you know, I mean, here, we'll just kind of look at this here again. Yeah. So we can select it this way, which is, that's fine. I mean, you know, we could say, first name, last name. and, you know, do some other things and, you know, give them this. But those column headers are kind of ugly, you know. I mean, if you're providing a report, you kind of want to dress it up just a little bit, you know. I mean, it doesn't have to be super fancy, but I thought that's a good opportunity to kind of show you guys the use of some other functions, and then also just concepts like concatenating, you know, things together and formatting and stuff like that. So this select kind of has some of those things in here, and I made notes to the right to just kind of indicate like what are we trying to show here. So aliasing for, you know, user-friendly consumption, for, you know, first with a capital F space name with a capital N instead of just first name, right? It makes it easier for the users to consume the data. I'll highlight line 173 because this has a lot going on in here. So we have the date part. So I just wanted to grab, you know, the birth date is stored as a date time or date, but you know, it's the whole thing, right? It's a year and a month and a day. Well, I don't want to put that in a report that goes out in a, you know, a list that's going to go out in a newsletter. You know, I want it to say December 1st and not, you know, 12/1, 20, it wouldn't be 20, but you know, 1975 or whatever it is, right? So I just want, you know, I want to parse out just the month, right? And then kind of like, you know, we would if we're typing it out ourselves, you know, month / you know, year. And I didn't want to provide, or sorry, month / day, but I didn't want to provide the year because, you know, we don't want to be sending out emails like telling everybody how old everybody is. Some people may not like that, right? So I was like, well, I don't really want that part, you know. I just want the month and the day, and then a separator in between. So you know, parsing out the month from the date, from the birth date, and then concatenating in that /, and then parsing out the day. And I have to take the whole thing, because those are numbers, right? I've just parsed out, this person, I think it was like 7 something. Let's just say it's 12/1. So I've just parsed out a 12 and a 1. And if I try to concatenate those together with a character, which, I hate it when it does that. With a character, there we go. The // whatever, which is a string, SQL is going to have a problem with that, regardless of what kind of SQL you're using. It's going to say, no, you can't add, you know, some, you know, these are numbers. You can't add this number and expect it to be a string. So I had to say, okay, cast it as text. Yeah, and actually I'm kind of cast this as text, cast, you know, this section as text. And then concatenate the whole thing together, right? So I got, you know, a number for the month, a / and a number for the day. That may be a very long explanation for what may seem obvious, but may not be obvious to everybody. So anyway, and then at the end, I'm giving it a friendly name. It's their birthday, instead of, you know, this piece of that plus that. You know, same concept here. This is an illustration of. I originally thought I'm going to use a date diff. I'm going to say, okay, what's the date difference between this and this? And it just is kind of weird the way it worked. So I changed my mind. I was like, all right, then fine. You know, it'll just be the year of now minus the year that they were hired, and that'll give us you know, some number of years that they've been here. This is the select I actually started with before I realized I was going to have to bring in the pay, a table, not the pay, but the department history where there may be multiple records because maybe that person's moved around in the company, right? So I realized, okay, I'm going to have to figure out, again, what is the max record. I don't really want to say happy birthday to Jane and report that, you know, she's in production when now she's, you know, in HR, whatever, right? Or report 3 Janes if there were 3 records because she was in 3 different departments. We just want the current one, right? So this is just illustrating another way to get something, get the max of something. This is another built-in function. It's called coalesce. And I like this one. Coalesce basically is a function that takes parameters of of either columns or values. So I used both here to kind of illustrate that. And it selects the first non-null value. So that means go look at the end date, and if there is an end date, you're going to select it. But if there isn't one, i.e. they're still in that department, then select this way future date that doesn't ever exist. It's not ever going to exist while my code's around anyway. And if that result is that way future date, then join on that. So that effectively gets us our current record. So we're going to run this. You may have already done this. So now you can kind of see, okay, I mean, there's only one person here, so we could actually run this without the where clause. Let's just do that. So we can kind of start to see, okay, we got this nice first name and this nice last name and then what department they're in. And again, I think I started out with job title and took it out because I thought that's kind of weird, because the job titles were coming back kind of weird. With like number codes in them and things. I was like, oh, that's not too friendly for a newsletter. So, we got Ken Sanchez, executive, birthday's on January 29th, and you've been with the company 10 years and so on, with all these people. One of the things that you can do and you should do, and I did not do because I don't know how to do it in Postgres, and I didn't want to have that hold up, like creating the content to fill out this whole all these concepts that we want to go over, is order it.
Oh.
Or, say that, the birth date is a certain thing. Or parse it out to make it December instead of 12.
That's what we're doing right now.
So I think uncomment that, add an and to add it into my where clause. We should get, oh, I had it right. Comment out the last name piece because we want everybody, not just Laszlo, because Laszlo has a birthday in July, so they're not going to get returned for birthdays in December. So we could say, okay, return everybody who's got a birthday in December. It's like 12. And then, again, I don't know how to do it, so I'm not going to try to wing it on the fly when we got other stuff to cover. But you could basically go in here and you could order it, you can order it, but it's going to order it in numbers, and it doesn't order it friendly. In other words, it's going to do 12.1 and then 12.11, 12.12, and so on, and then it'll get to 12.2 and like that. So I figured, okay, it's probably going overboard. We need to show like all the functions and all the things in one select. So, but you kind of get the concept, I think. So this could be an example of, something as a database administrator, not administrator, developer, I guess, that you may be asked to do. But you could very easily see how this could be adapted to, okay, now show me like, which widgets sold, the most things, or, what salespersons landed, what customers and what date, and so on, right? Lots of, ways that this can be adapted to the business situation. So, running short on time. All right, we're going to speed it up a little bit. Okay, so I did get an ask for aggregations. And aggregations is basically math functions to add up, sum up, count, find minimums, maximums, all those kind of things in data. So we're just going to kind of run these and try to go through them real quick. So this is saying, in our product table, what's the minimum price? It's 0. What's the maximum price? It's almost $3,600. And how many products do we have? We have 504. So that's an illustration of minimum, maximum, and count. These are aggregation functions. So that's kind of, okay, that's fine. Like maybe I'm gonna have a KPI and a report. It's just a number, but it doesn't really give me much body or context or anything like that. Same thing here, with just another example, how many products were ordered. We had 274,000. So, okay, but I want some more detail about that, like what products were ordered, how many of which products were ordered, right? So, you know, that's, you know, when you start kind of, you know, digging into some detail and, you know, giving the business, some more actionable information that they may want. I didn't go the extra step and like, you know, figure out, well, what is, you know, I could join this back to, you know, the product table and figure out what is the product name, because, you know, no, not likely that somebody's gonna be like, oh yeah, you know, product 870, that's awesome, we sold 6,800 of them, you know, but they're gonna wanna know what product is that, you know? So that would require another join to bring that in. But this is kind of an example of, I do this kind of stuff all day long, you know, how much of this, you know, how much of that, and that kind of thing. So, well, actually, in my example, it turns out I did do it. So, let's see here. Okay. I skipped over explaining something, so I'm just going to explain it really fast. In this example here, you can see I'm selecting the sum of something as some other name to give it a name from a table, right? You don't see a group by here. So in this one, you do see a group by. So you may want to know, okay, what does that mean? When do I use that? You know, what is that? So it's essentially taking that sum or that aggregate function, if it's a count or whatever, and you're grouping it into little sums by the thing that you are grouping by. In this case, the product ID. So it would make it more meaningful to know how much of which product ID, not just that we sold a ton of stuff. Okay, well, what stuff? You know, which one's selling well? Which one are we not selling anything of, right? So I, again, wanted to point out the group by, because down here, you know, I kind of took this select and built it out even more, so that not only can we see, just select without the, you know, the extra add-on bits that we'll talk about. So we have the name now. Okay, that's great. You know, it's not product 870. It's a Mountain 100 black number 38. You know, so like it's a mountain bike. So I know what it is. If I'm managing the sales of those kind of products, I'm going to know that. We may be interested in, okay, which ones did we sell 5,000 or more of? So I just uncommented line 220 and was able, you know, to add that into my select there, and said, oh, okay, now there we go. I got 6 records where the product sold is greater than 5,000. Conversely, you know, that's showing your top sellers, right? And you may know that, right? Because you're selling a lot and they're popular and you're talking about it all the time and you can't keep it on the shelf and warehouses, you know, pumping it out the door. We know about those. What am I not selling, you know? And I may not know what number that is, so maybe I don't look for it by saying that it has to have a certain sum of an amount. Maybe I don't know what that amount is. Maybe, you know. So what I can do, a different way to approach that kind of problem, is I can order this whole list, right? So I've got a count, and I've got some products, and I order it from least to greatest, or greatest to least. It just depends on what you're looking for, really. The way that you do this in Postgres is very different than the way that you do it in Microsoft SQL. And, well, it's just written differently. So here we're going to order it and we're going to limit. So I'm going to order descending and limit to just 10. And that's going to give me my top. But if I say, okay, order it ascending and limit it to 10, that's my bottom. These are the things that are not selling well. So do we want to spend money, you know, maintaining the relationship with this vendor whose products we can't sell? Or, you know, wasting space on the shelf to hold this stuff that's not going anywhere, right? So this is helpful information. It's actionable for the business. All right. That's a whole lot of like running selects and talking about stuff. And so now we're gonna take a break from that. Everybody doing fine? Have I lost anybody? Y'all good? Awesome. Okay, so we're not gonna do any examples of the next bit, but we are gonna talk about it because it is a question that comes up a lot, and it's good to kind of talk about indexes. What are they? Why do you want to have an index? How do you put an index on? When do you do it? And yeah, this is a slide I'm kind of cheating on, so it's really like what I want to say on this slide. So an index is, it's a structured way to organize your data, typically in an order, and that's going to allow SQL Server to get your data more quickly, check and see if it's unique, or force it to be unique, and improve performance. So next biggest question is when do I need an index? That's great. It's going to make it more performant. When do I need an index? You need an index on columns that you will be joining on or using the most. And oftentimes that's the primary key. And by default, when you create a primary key, it automatically puts what's called a clustered unique index on the primary key unless you specify otherwise. That may not always make sense. It may not always be the best thing because maybe your product or your primary key isn't really business relevant to like all the other selections and manipulation you're doing with the data. So indexes are complex, and we're probably not going to be able to answer all questions tonight right now, but it'll give you kind of some food for thought, and there's a ton of reading out there about this topic in great detail to give you more information. But mostly it's on the primary key. You can also put it on the foreign key because the foreign key is going to exist in this table because you're going to join over to that table. Effectively, you're putting a join on the table. You want the results to come back quickly because if you got 10 million rows here and 5 million rows there, SQL Server needs to be able to like sift through that data quickly and find it. So another time you may need an index is when your query is just dog slow. So you're running this query and maybe it was great and it worked fine when you built the table and there were like 2,000 records in it, but now you got 10 million records in it, and when you run that stored procedure that is querying data and trying to pull some result, and it's just taking 20 minutes to run, you're like, oh man, I must need an index somewhere. So I don't know what the tool is in Postgres. SQL Server, Microsoft SQL Server does have a query analyzer tool that you can feed it in. Hey, this is the query I'm trying to run that's just so terribly slow. Analyze it for me and tell me what indexes I need. I already have one on the primary key, and I already have one on a thing I'm joining on, and it's just not clear to me, like, what else can I do? I know I need an index, but where? So it'll analyze the query and tell you, this is where you need to put an index. So that all sounds good. It sounds like I should just be putting indexes on all the time. Just index, index, index. You have to be careful though, because you can create too many indexes, and that can cause performance issues. It's like a delicate balance because the indexing process is very resource intensive, especially when you're doing regular maintenance and you're rebuilding your indexes as your data grows to make sure the data is organized and the index can still quickly get to the data that you're looking for. So you have to do a few things. You should identify, and we talked about this a little bit in the previous slide, but identify the column that makes the most sense for the primary sorting order, which is that clustered index. You can only have one clustered index on a table, and that determines the actual sort order of the actual data in the physical table. Non-clustered indexes are just like, they're ordered lists, but they're pointers back to the data. So you have to, you want to make good use, like, am I putting the clustered index on the right thing? The thing that I'm going to be searching the most. Most of the time it's the primary key, but not always. So you only want to create and also keep indexes that you're actually using. Maybe 4 years ago when you were using some other system or you were using this data a lot, it made sense to have 17 indexes on this table, and it just doesn't make sense anymore. But now SQL Server is going to have to like, rebuild these indexes all the time. There's no point in keeping them, just like any code. If you're not using it, you don't keep it. If you have indexes that are similar, you can consolidate them together. There's no point in having multiple indexes on, customer address or whatever. Put it on one or put it on fewer, and then regularly audit them and maintain them. This is one of those tables I debated putting in here, kind of like the relationship entity diagram from last time, because it was just like a lot of stuff. But I think it's a good idea. So if you kind of take a look at this, we have a user, a customer, an address, and an order. And again, this is in the slides. You can look at it later in more detail. But it just kind of gives you an idea, like, what kind of index you would put, if any. Maybe it makes sense for it to be clustered in one case and not.
What does cluster mean?
So clustered is the type of index that defines how the data is actually sorted in the table. You can only have one on a table. So non-clustered doesn't dictate the sort order of the data. It's actually a separate index outside of the table that has an ordered list that points to data in the table, but it's not how the data in the table is ordered. So there has to be some communication here between the non-clustered index and the clustered index, because this non-clustered index is going to point to a pointer in the clustered index to get to the data. So it's slightly less, yeah. Like there's a lot of information about indexes.
Basically, the index doesn't actually go with the actual data and the order's in. It's just like, here's your list.
Yeah.
Here's your actual data and your list of your data.
Yeah.
They don't really go together.
Yeah.
Those
Yeah.
assign random numbers to them,
Yeah.
not based on order.
Okay.
Yeah.
Got it.
Yeah.
Interesting.
I mean, it's honestly, it's a topic that it's actually deeper than it seems like it would be. But I also was like, so I was like, I don't know if I want to talk about indexes, but everybody wants to know about indexes. So I was like, well, I have to talk about them somewhat, So this is as far as I wanted to go with indexes. So y'all can, check that out later if you want, but it just kind of gives you an idea. Like you can think about, oh yeah, user ID definitely gets a clustered index. Whereas, down here, this order ID in the order table, they're putting a non-clustered index because they're using the user ID and the created more often. They're probably going to create that as a composite key and put the clustered index on that. Composite meaning a key that's made up of two different columns together instead of one. All right, so.
Still on time?
All right, almost. Okay, I'm gonna go faster. All right, so views. People have asked about what views are. Views are not actual physical tables in the database. Views are a set of logic that you can run that will return you a result set of data that's virtual. So it doesn't actually sit on the disk, but you can query data and bring it back to you. In my experience, this is it's always done for reporting, because I don't want first name with no spaces and hire date with no spaces, and and I don't want date time formats that have all of the the hour, minute, year, or millisecond, and all. I don't want all that. I just I want something friendly, right? So this is where you're gonna this is kind of like a bring it all together sort of concept. You're gonna start using all those functions and all of those ways that you can join and manipulate data to really distill it down to just what you want. It may be for a report, or it may be to feed into another system because the other system has to see the data this way, but you have the data that way, so you have to change it. It can be for a lot of reasons, but some of which are illustrated here. But the point is, it's a virtual result of data, a data set result of running a query that typically is serving a business use. Does anybody have any questions about views? Because that's really all I was going to say about views, unless you want to know more. I was trying to keep that one like super simple. Good? Okay, cool. So, because if we can get through all this stuff, I'm going to show you a real world example that I was working on at work yesterday that has all this stuff in it. All of it. Okay, so procedures. Okay. So earlier we talked about functions, right? And the question that comes up a lot, if you take like a certification test on any database system, they'll probably ask you this, like what is the difference between a function and a stored procedure? So so we talked about functions. They take an input parameter, maybe, actually definitely. They take an input parameter, they select some data, they return you a result. And you use it in a select statement. Select function, parameter, you know, yada yada, and you get your result. Stored procedures are more powerful because they do more things. You can select data with a stored procedure, and I have some at work that we do that. That's all it does, it just selects data. But it has the potential to do a lot of other things. Insert data, update, delete, create tables, you know, run other logic, send emails, all kinds of stuff. So they're more powerful. They can, but don't have to take an input parameter. They can, but don't have to return a result. Maybe they're just doing something to data, and then you're just like, all right, I'm done. You know, I went and inserted all these records, done. That's all you get. You know, you don't get back a list of what happened. So it's prepared, it's saved, you know, very similar to a function. It is pre-compiled. So it automatically, you know, it runs pre-compiled, whereas functions are compiled on the fly when you run them. In case anybody wants to know that trivia. I just wrote ideas here because just to kind of get your brains thinking about, okay, stored procedures are really powerful, awesome. Like what could I do with a stored procedure? Typically, like anything that you do in coding, you're going to name it kind of like what function is it serving, what is it doing. And most commonly, naming convention is to put SP in front of it, indicates that that object is a stored procedure. So these don't really exist, I just made these up on the fly, but just for examples, right? I'm going to have a stored procedure to create a new customer, maybe update their address, or load this data, or make it, you know, calculate interest, you know, make some kind of aggregate calculation and do something with that data. So, not there yet. So we'll go back over to Postgres, and scooch this down a skosh. All right, so I made this one at first, and I don't think we're going to run it here tonight. You can run it if you want to, but mostly what I was trying to illustrate was stored procedures can do a lot of stuff. So instead of like a function, just select data a certain way, you know, this stored procedure is raising a notice. And it's also concatenating in my input parameter, which is some kind of text value. It's creating a table. Super basic table, but you know, creating a table. Inserting data into that table. In fact, it's inserting whatever parameter I'm passing to it. And then randomly, just because again, I just wanted to show it could do lots of different things. This doesn't make sense, I would never do this. But it's updating that table. So, actually, we'll run it because we're talking about it, so we'll just do it. All right, so we're gonna create the stored procedure, which I just did. If there's any kind of, you know, syntax problem, it'll let you know, but otherwise, you know, return successfully. So now we have the stored procedure. So if I go run it, I'm going to call it, and then I'm going to pass it the parameter of Liz. So basically, it's showing me it has P1 Liz, and also there's my notice. Hello, Liz. So that's my raised notice back up here. If I go look at that table though, it's got Janet. You can see I've run this a couple times because Janet's in there more than once. So why does it say Janet? Because I passed Liz, right? Well, it says Janet because just arbitrarily, I just to show it could do a lot of stuff. Not that you'd want to do this. I just decided, all right, fine, just, you know, wherever it says Liz, update it to Janet. So just illustrating can do a lot of stuff. Something kind of more real world, it's very rudimentary and broken down to be kind of simple, is, okay, now I want to have a stored procedure that I can embed in my either application code or website code that when users put in some data, we go store it, right? So I was, again, trying to think super simple. Let's just capture a name and an email address and log that we did that, right? So in order to do that, I had to create some create statements because I got to have somewhere for that data to go. So I'm going to create these two tables. Oh, I know it. All right. The reason why I got that error is because I was trying to run the create of two different tables and I didn't put a semicolon at the end. Because in Microsoft SQL, it is not required. So I'm not used to doing that. So when I run multiple statements, Postgres wants it. And, yeah. Anyway.
Delete the column before this.
Too many. Yeah. Thank you. Appreciate it. Okay. There we go. All right. So now I have these two tables. In my public schema, I've got an audit log table and an our customers table. And I'm going to scroll to here just so we can kind of see it. Actually, again, Postgres, you got to run one at a time. Microsoft SQL, I can run both. There's nothing in my customers table, and there's nothing in my audit log table. So now what I'm going to do is I'm going to create this procedure. I don't know if I already have it or not. We'll find out. So the new procedure is going to create a new customer. It's going to take in the customer name and the customer email address. So maybe you've got like some application or web code, and somebody puts those in. They get captured in variables, and those variables are going to get passed into the stored procedure, right? The stored procedure will be expecting a customer name and an email address, and when it gets them, it's going to take them and insert them into the our customers table, and then after that, it's going to create an audit log, some kind of entry indicating, hey, this happened at this time. So now I'm going to say, now that I've created the stored procedure, run it. Now I'm going to call it, and I'm going to pass in Jane and email Jane at email.com. So now we can see that our customers has this data in it. And also, just to talk about audit logging really quick, this is super basic, but it kind of opens the door to possibilities, or maybe gets your juices flowing about what you could do with this. So you could, I don't know, capture the IP address of the system that this came from, and also put that in this log table, or a username if they're using an app and they're authenticated and they're on your domain and you got control of all that stuff, so you can capture it. You can throw that in the audit log table. Audit log tables are awesome. It's very good to know what happened, when did it happen, how many of it, who did it, all that kind of stuff. For later on when you're trying to figure out problems, or how did it get this way, or who do we need to go back to talk about this, those kind of questions. And then just because it's always good to know how to delete stuff, delete from, and then you can just blow it away. If you don't have questions you remember later, you just email me at highliz@fastmail, and or just hit me up in Slack or whatever. I may not have the answer. It may take me a couple days to chew on the problem, so I always come back with an answer.
She will respond. I promise.
Yep. Yeah, so anyway, I hope you enjoyed it. I put a lot of time into trying to teach you guys some basic concepts. And, you got any feedback for me? Things that you'd like to see, or things I could do differently, to make a better learning experience for you, definitely love to hear it. So, thank you.
Nice.